Good morning, my dear students. It gives me great pleasure to talk to students through video presentation like this as usual. You can share the videos with your friends and relatives. You can advise them to subscribe by clicking the subscribe button as well as the bell icon and watch. Subscription has no charges. The very idea of subscription is to get automatic notification about the new videos being uploaded in the channel. This video presentation deals with the last two sums of Model Paper 3 of Class 12 CBSE Maths Term 2 paper. The question goes like this. It is the 13th question in the same paper. Find the distance between 1, 0, 1 and x plus 2y plus z equal to 4 measured parallel to x minus 1 whole by 1 is equal to y plus 1 whole by 1 is equal to z minus 3 whole by 1. This is the question. Just see here. This is the question. You can read the question if you want. It occupies more space if I want to write it down on the board. Okay, let me just draw a rough diagram. This is the plane given to you. This is the line given to you. Okay, this is the point, let us say A101. This is the point. The plane here is x plus 2y plus z is equal to 4. The line here is x minus 1 by 1 is equal to y plus 1 by 1 is equal to z minus 3 by 1. Okay, I need to draw a line parallel to this, let us say. Okay, now you can even write down, let the given point be A101, given plane is x plus 2y plus z is equal to 4, I'll name it as 1, given line, I'll name it as 2, x minus 1 whole by 1 is equal to y plus 1 whole by 1 is equal to z minus 3 whole by 1. Just listen carefully. Okay, line through A1, 0, 1 and parallel to 2 is, how do I get it? X minus 1 whole by 1 is equal to y minus 0 whole by 1 is equal to z minus 1 whole by 1. Instead of 1 minus 1 3, I'll write it as 1 0 1. X minus 1 whole by 1 is equal to y minus 0 whole by 1 is equal to z minus 1 whole by 1. Denominator should be the same. That's the real meaning of they are parallel. Okay, the DRs are the same if I use the same denominator. Now, general point on 3 is, how do I get it? K plus 1, K plus 1. Okay, let line 3 intersects plane 1 at B. Let this point be B. Okay, substituting k plus 1, k plus 1 in 1, we get, what do I get here? K plus 1 plus 2k plus k plus 1 is equal to 4. Are you able to follow? Now here you mean to say 4k is equal to 2 implies k happens to be half. Now for my point B now becomes half plus 1, half plus 1, that is 3 by 2, half, 3 by 2. For my required distance is nothing but AB. My required distance is simply AB. Apply distance formula. What do I end up with? 1 minus 3 by 2 the whole square plus 0 minus half the whole square plus 3 by 2 minus 1 the whole square. Let me just write the simplification over here, which is equal to root of 1 by 4 plus this is again 1 by 4 plus this is again 1 by 4. Therefore, this is reduced to root 3 by 2 units. That will be the final answer. Let me just repeat. I am supposed to find distance between 101 and plane x plus 2y plus z equal to 4 measured parallel to this line. That's the meaning. I assume the given point is A101. Given plane as x plus 2y plus z equal to 4, equation 1. Given line x minus 1 by 1 is equal to y plus 1 by 1 equal to z minus 3 by 1, equation 2. Line through A101 and parallel to 2. I need to draw it parallel to this. Remember, that's a very idea. Okay, now name it as 3. General point here is if I equate it to k, I'll get it in terms of k. If I equate it to lambda, I'll get it in terms of lambda. If I equate it to mu, I'll get it in terms of mu. For k plus 1, k plus 1. Let this line intersect. This should be only intersect, not intersects. Let line 3 intersect, not intersects. Intersect plane 1 at B. This is the point. Substitute this point over here. K plus 1 plus 2k plus k plus 1 is equal to 4. And for 4k is equal to 4 minus 2, which is 2. Therefore, k happens to be half. Okay. Now for B happens to be half plus 1, half plus 1. 3 by 2, half 3 by 2. Now required distance is supposed to be required distance AB. For 1 minus 3 by 2 the whole square plus 0 minus half the whole square. For 3 by 2, or you can say 1 minus 3 by 2 whole square, 3 by 2 minus 1 whole square. Either way you can write, I am sorry, 1 minus 3 by 2 whole square. Remember carefully. 1 minus 3 by 2 whole square, 0 minus half, everything is written only from this, therefore 1 minus 3 by 2. Better write 1 minus 3 by 2 here again. Now for taking LCM, that is minus half whole square, 1 by 4, 1 by 4. This is also 1 by 4. Now for root 3 by 2 square units, units will be the answer. Units, sorry, not square units, units. Simply a distance. Okay? That is how it is being done. This is the last problem, goes like this. The last problem in this paper, which goes like this. It's a case-based question, or just listen carefully. It's not a difficult one. It's as easy as any other problem. I'll just explain. Just see here. Boy A is standing at the point x 1, 2, 3. Boy B moves around the plane x plus y plus z equal to 3. And he starts at the point which happens to be the foot of the perpendicular y from x to the plane. Find the distance between the two boys now. This is the question. Just see the question now. I'll show it to you for 2 minutes. Okay, let me just see here. The answer will go like this. Okay, let me just draw the diagram. This is the plane. Okay, this is the point x 1, 2, 3. Okay, this is the plane x plus y plus z equal to 3. The boy moves over here. At one point in time, he stops at y. Y happens to be the foot of the perpendicular. Practically speaking, after finding the foot of the perpendicular, apply distance formula. What is the distance between the two boys? That's a question given to you. Okay, this is my plane. You can write down x 1, 2, 3 is the given point. Xy perpendicular plane, y is the foot of the perpendicular. Given plane is 1, so you can write. Let y be x1, y1, z1. Just listen carefully. Now drs of xy vector or line xy, either way you can write, or I'll get it to be x1 minus 1, y1 minus 2, z1 minus 3. Okay, drs of normal n vector to 1, you call it as n vector here. Okay, or what are they? 1, 1, 1. Okay, now xy vector and n vector are parallel. See the diagram. Therefore, they both have proportional drs. Proportional drs. Two vectors or two lines are parallel in 3D if and only if they have same drs or proportional drs. Therefore, I will write it as x1 minus 1 is equal to k, y1 minus 2 is equal to k, z1 minus 3 is equal to k. Therefore, x1 happens to be k plus 1, y1 happens to be k plus 2, z1 happens to be k plus 3. Now, y is a point on 1. Y satisfies 1. Y satisfies 1. For x1 plus y1 plus z1 is equal to 3. Just listen. I mean to say k plus 1 plus k plus 2 plus k plus 3 is equal to 3. Now 4, here anyway 3 gets cancelled. 3k is equal to minus 3, which implies k happens to be minus 1. Therefore, my y becomes, y is minus 1 plus 1, minus 1 plus 2, comma, minus 1 plus 3. Therefore, y is 0, comma, 1, comma, 2. Therefore, required distance or distance between the two boys, required distance is nothing but xy. Let me apply distance formula. 0 minus 1 the whole square plus 1 minus 2 the whole square plus 2 minus 3 the whole square, which is reduced to 1 plus 1 plus 1, which is root 3 units, Let me repeat the whole process, just listen carefully. You are given point x 1, 2, 3 at where one boy is standing. Another boy is moving around the plane x plus y plus z equal to 3. At one point of time he stops at y, where y happens to be the foot of the perpendicular from x to the given plane. What is the distance between the two boys? That's a question given to you. I assume y to be x1, y1, z1. dr's of xy vector, a line xy, either way you can write, or x1 minus 1, y1 minus 2, z1 minus 3. dr's of normal n vector to 1, or the coefficients of xy, z, 1, 1, 1. xy vector and n vector are parallel, therefore they both have proportional dr's. Therefore x1 minus 1 should be equal to k, y1 minus 2 should be equal to k, z1 minus 3 is equal to k. Therefore x1 becomes k plus 1, y1 becomes k plus 2, z1 becomes k plus 3. Y is a point on 1, therefore y satisfies 1. x1 plus y1 plus z1 equal to 3. K plus 1 plus k plus 2 plus k plus 3 is equal to 3. Therefore k plus k becomes 3k is equal to minus 3. K is minus 1. Point y now becomes minus 1 plus 1, minus 1 plus 2, minus 1 plus 3. 0, 1, 2. Now required distance will be distance between the two boys. That is the required distance xy. 0 minus 1 whole square plus 1 minus 2 whole square plus 2 minus 3 the whole square. That is 1 plus 1 plus 1, root 3 units. Therefore distance between the boys now happens to be root 3 units. I think this ends the last problem in the particular paper. For the whole paper is covered in almost different videos. I think maybe 6 videos, I believe. Okay, thank you students for patient watching. And if you feel that it is really good, share it with your friends and advise them to subscribe and then watch. Thank you.